Welcome. In this video, we'll explore a key concept in microservices architecture, service registry and discovery. In a distributed system with many microservices, services need to find and communicate with each other dynamically. That's where service registry and discovery comes in. It acts like a phone book for services, enabling them to register their availability and discover others in real time. Let's dive in. To understand how this mechanism works and why it's essential for scalable and resilient microservices. Before we jump into the details, let's take a quick look at what we'll cover in this video. First, we'll look at the problem. What was the challenge before service discovery came into play? Next, we'll explore how service discovery solves that problem, bringing automation and flexibility to service communication. Then we'll break down how service discovery actually works in a microservices environment. And finally, we'll discuss the different types of service discovery and when to use each. Let's get started. Before service discovery was introduced, especially in Spring Boot microservices using tools like Eureka, developers faced several challenges in managing how services located and communicated with each other. Let's break down the main problems teams used to face before service discovery came into the picture. Let's take a look at this diagram. It represents a basic microservices architecture with three separate services. In this setup, each service is deployed independently and exposes its functionality through a specific URL. Now here's where the challenge begins. If a client application such as a front-end mobile app or even a third-party system wants to interact with any of these services, it must know the exact URL of the service it needs to communicate with. This means the client is tightly coupled to the network location of each service. The same issue applies when one service needs to call another. For example, if service A wants to send a request to service B, the developer has to manually hardcode the full URL of service B inside service A's code. This tight coupling introduces several problems. For example, 1. Hard-coded service locations, 2. Lack of dynamic scalability, 3. High configuration overhead, 4. Poor fault tolerance. We'll discuss these problems in the next slide, but for now just keep note of these 4 points. In short, this architecture lacks flexibility and it increases complexity as the number of services grows. That's why we often introduce tools like API gateways or service discovery mechanisms to decouple services and make communication dynamic and manageable. 1. Hard-code service locations. The first major issue was that services had to know the exact network locations, like IP addresses and port numbers, of the other services they needed to talk to. This meant that anytime a service location changed, you had to manually update configuration files or even the code itself. For example, let's say your user service needs to call the order service. You might hard code a URL like http://192.168.1.100:8080.orders. This makes the system rigid and highly prone to failure if anything moves or changes. 2. Lack of dynamic scalability. Without a proper service registry, scaling services up or down became a complicated manual process. Let's say you scale your payment service from 2 instances to 5. You'd have to manually update every client and load balancer to reflect the new instances. There's no automation here. Clients don't know when new instances come in or old ones go out. That breaks the whole point of having flexible, scalable microservices. 3. High configuration overhead. In these setups, each service had to maintain its own list of dependencies and their addresses, usually stored in properties files or environment variables. This leads to a huge configuration burden. Every time you deploy or switch environments, whether it's dev, QA or production, you have to manually update all these configs. That increases the chance of human error and slows down deployments for everyone involved, especially the DevOps team. 4. Poor fault tolerance. The last issue, and one of the most critical, is fault tolerance. If a service instance goes down, clients are often unaware. They keep trying to reach the same dead service again and again. This leads to increased latency, unnecessary retries, and sometimes complete application failure. For example, the app might hang or even crash because it's still calling a service that's no longer running. These 4 problems show why static service communication just doesn't work at scale. And that's exactly where service discovery comes in, bringing automation, resilience, and flexibility to your architecture. Now have a look at this code snippet. As we know, a REST template is a simple HTTP client provided by Spring that helps us make REST API calls like get, post, and so on. Here we are creating a REST template object which lets us send HTTP requests. And since we are not using service discovery, we are creating it manually instead of letting Spring automatically configure it. Here's the line. String URL is equal to http://localhost 8081/products load plus ID. This is a hard-coded URL to call the product service. It assumes the product service is running on port 8081 and has an endpoint like /products/IPC. This class is responsible for calling the product service directly using a fixed URL. It builds the URL with the product ID, sends a request using REST template, and returns the result. There is no service discovery, no dynamic lookup. The address is hard-coded. Now this might work fine for small apps or during development, but it becomes a big problem in real-world dynamic environments. Now you might be thinking, how does service discovery and registry solve this problem? Let's have a look at the diagram. Alright, let me explain how service discovery and service registry actually work in simple terms. So imagine you're building a system with a bunch of microservices like an order service, a product service, and maybe a payment service. Each one is running separately, maybe on different ports or even on different servers. Now here's the tricky part. How do these services find each other, right? We can't go around hard coding IP addresses and port numbers in every service. That will just become a big mess, especially as the system grows. That's where service discovery comes in, and it does exactly what it sounds like. It helps services discover each other automatically. But how do they do that? Well, with the help of something called a service registry. You can think of it like a phone book or maybe a contact list for your services. Whenever a service starts, like let's say the order service, it goes to the registry and says, hey, I'm up and running, you can find me here. Then later, if another service like the API gateway or maybe the product service wants to talk to the order service, it just checks the registry and asks, hey, where's the order service? And the registry replies, yep, it's running at this address, go ahead. This way, services don't need to remember addresses, they just look them up when needed. Pretty neat, right? And the best part, it's dynamic. If a service restarts or changes its location, it updates the registry, so everyone else always gets the latest info. Now without this system, you'd have to manually update URLs everywhere, and that can break things really fast. But with a service registry like Eureka or Console, the client just needs to know the name of the service, and Eureka handles the rest, like where it's running, how to balance the load, or even if a service goes down. So yeah, services just ask the registry for directions. It's like using Google Maps instead of asking around for someone's house. And that's how service discovery and service registry make microservices work smoothly and smartly. There are mainly two types of service discovery you'll come across. First is client-side discovery, where the client itself is smart enough to find and connect to the service directly. It asks the service registry, gets the address, and makes the call. Then we have server-side discovery. In this case, the client just sends the request to something like a load balancer, and that load balancer looks up the registry, picks the right service, and routes the request. Now in more modern setups, we even use something called a service mesh like Istio, which handles discovery, traffic control, security, and even observability all behind the scenes. So yeah, depending on your architecture, you can choose the method that fits your system best. Let's talk about some common components used in client-side service discovery. First, we have Netflix Eureka. This acts as the service registry where services register themselves and discover others. Then comes Spring Cloud Netflix. It provides the client-side functionality along with a built-in load balancer that helps choose which service instance to call. Another popular option is Console. It also works as a service registry and is widely used outside of the Netflix ecosystem. And finally, there's etcd, a lightweight and reliable key value store that can be used for service registration and discovery, especially in Kubernetes environments. So depending on your stack and requirements, you can choose the one that fits your needs best. On another hand, we have popular tools used in server-side service discovery. Kubernetes comes with built-in service discovery using DNS, often handled by core DNS. This lets services find each other automatically within the cluster. Then we have Envoy and Istio. These work together as a service mesh handling traffic routing, security, and observability through sidecar proxies. In cloud environments like AWS, we use Elastic Load Balancer or ELB. It's a classic example of server-side discovery where the load balancer knows where to route the request. There are also tools like Nginx and HA proxy, which act as reverse proxies and route traffic based on dynamic service registration. And finally, Console can be paired with Envoy to create a powerful service mesh setup, giving you fine-grained control over how services communicate. So with server-side discovery, the logic of finding services is handled outside the client, making things simpler and more centralized. Do you have any questions? Leave a comment below. I'd love to hear from you. And if you found this helpful, do support the channel by hitting like and share. Don't forget to subscribe for more upcoming videos on microservices, Spring Boot, and other tech topics. Thanks for watching and see you in the next one.